Good morning. I'm Jin Jun from Xinjiang Oilfield Company. Today, I would like to discuss phase behavior of the mid-Carboniferous near critical condensate gas reservoirs in Yang'an Basin. My co-authors are Tuo Hong, Zhou Wei, Wang Ziqiang, Ma Yu from Xinjiang Oilfield Company, and Chen Hao from China University of Petroleum at Beijing. Last year, we had a great discovery in the mid-deep reservoir in the Yang'an Basin. The well area is located in the Carboniferous system, Luliang uplift. The well depth is over 5,000 meters. The central pressure and reservoir temperature is 68 MPa and 127 degrees C. It has very good physical properties, dual medium characteristics, and sufficient liquid supply capacity. As the well testing curve shows, the well has very good production performance with stable production and stable pressure. After perforation, high-yield oil and gas flow was obtained with a peak oil and gas equivalent of over 2,000 cubic meters. The well test performance of the well X can be characterized by two high and one low, which is high oil production, high gas production, and low gas-oil ratio. This is totally different from other gas reservoirs in Yang'an Basin, and it is the gas reservoir with the lowest gas-oil ratio discovered in Yang'an Basin till now. When the nozzle size is between 4 to 9 millimeter, the oil and gas increases. The oil and gas production increases with the increase of the nozzle size. It obeys to the characteristics of a gas reservoir. However, when the nozzle size is higher than 9 millimeters, the oil production is sharply decreased, and the gas-oil ratio is greatly increased, and it behaves more like an oil reservoir. As is well known, Yang'an Basin is rich in oil and gas reservoirs, including heavy oil, black oil, volatile oil, condensate gas reservoirs, wet gas, dry gas reservoirs. But the well test results in well X and well Y show very special characteristics. So what is the reservoir type of these two special wells? This is very important because we have to formulate development plan according to the reservoir type. To answer this question, we conduct PVT test and theoretical analysis. So firstly, PVT test was conducted by the PVT analyzer of Vinci company in France. The maximum working pressure is 100 MPa, and the maximum working temperature is 200 degrees C. And the reservoir and pressure and temperature conditions, oil and gas samples were prepared according to the production gas-oil ratio of 890. And after the combination, the reservoir fluids of well X were obtained, and the PVT tests of DL, CCE, and CVD were conducted, and we found some very interesting phenomena and obtained the basis data such as the fluid composition and key phase parameters. And according to the CCE test, the reservoir fluid of the well X is transparent
Sorry, internet is not good here. We'll share screen again.
Condensate gas reservoir. The second phenomena is fluid stratification. We found it in CVD test. With the decrease of pressure, a large amount of condensate was formed rapidly, almost covering the whole window. The color was reddish brown in the beginning, and then it was divided into two layers. The upper liquid phase was yellow, and the lower liquid phase was reddish brown, and a clear liquid-liquid interface involved. The entire liquid phase presents a unique upper liquid yellow and lower liquid red stratification, which is another visible hallmark of near-critical condensate gas reservoirs, as shown in this figure. As the CVD test continued, the volume of yellow liquid phase in the upper part gradually increased, and the volume of reddish-brown liquid phase in the lower part gradually decreased. Finally, the whole liquid phase was yellow. Again, it was confirmed to be a near-critical condensate gas reservoir. So why this phenomena occurred? In fact, the stratification phenomena are caused by the significant density gradient of fluid in the near-critical region. Due to the density fluctuation, light scattering appears. It reflects the special properties of condensate in the near-critical region. At the initial stage of pressure decrease, in the process of gas-liquid separation, light components upward, while heavy components tend to precipitate on the bottom. Thus, there was a large difference in local densities between these two regions. A liquid phase presents a unique fluid stratification with obvious yellow and lower red phenomena. With continuous pressure reduction, the density fluctuation will become smaller and smaller, and the red bottom will gradually disappear. And these phenomena are very interesting, and it is the first time we found in our Yangtze Basin. We also obtained the fluid composition and K-phase parameters of the well X. As shown in the table, there are some K characteristics. Firstly, the difference between reservoir pressure and dew point pressure is very large, over 18 MPa. It is significantly larger than that of common condensate gas reservoirs in Yangtze Basin. Gas reservoirs such as Mahe, Mobei, and Klameili in Yangtze Basin are relatively small, which mostly distributed from 0 to 5 MPa. Secondly, the condensate content is as high as over 700, which is the highest among the discovered gas reservoirs in Yangtze Basin. According to the national standard of China, it belongs to extremely high condensate gas reservoirs. Comparatively, the condensate gas content of common condensate gas reservoirs in Yangtze Basin varies from 100 to 300. Thirdly, the maximum amount of retrograde condensate is as high as 26%, which is also the largest gas reservoir discovered in Yangtze Basin. Comparatively, the value in common condensate gas reservoirs in Yangtze Basin is between 3 to 6%. What's more, the methane content is lower, while the heavy hydrocarbon content is higher. Generally, methane content of conventional Yangtze Basin is between 85 to 92%, and heavy hydrocarbon content is only 1 to 3%. Obviously, the well X is different from that of common condensate gas reservoirs in Yangtze Basin, but similar to the typical near critical condensate gas reservoirs in China. Okay, according to oil and gas industry standards of China, technical requirements and determination of phase stage characteristics of condensate gas reservoirs, PVT methods are dominant, while the empirical methods are supplements. And PVT methods include phase diagram method, liquid volume ratio and dimensionless pressure curve method, condensate oil content and saturation pressure curve method. Okay, so this is the first method, PT phase diagram method. Okay, the right finger is the standard phase diagram of typical oil and gas reservoirs, and the left one is the PT phase diagram we obtained from the PVT test. Obviously, it matches the characteristics of typical near-critical condensate gas reservoir. Okay, second one. This figure shows the relationship curves between liquid volume fraction and dimensionless pressure of the well X, and it can be seen that it fits well to condensate gas reservoir with high condensate oil content. And the other one is the change curve of retrograde condensate volume during CVD test, and it fits well to the definition of near critical condensate gas reservoir. And the maximum condensate volume is rapidly reached once the pressure is lower than the dew point pressure, and the retrograde retro-condensation process is short, but the evaporation process is very long. Thus, it determines that the well X is a condensate gas reservoir with high condensate content and typical near-critical characteristics. The condensate content and saturation pressure curve of the reservoir fluids in well X is shown in this figure. This is the third method. It shows an opposite relationship of GOR and saturation pressure between conventional and near-critical gas reservoirs. For conventional condensate reservoirs, the lower the condensate oil content, and the lower the dew point pressure. While for the near-critical condensate gas reservoir, the lower the condensate content, the higher the dew point pressure. For both wells, with the increase of condensate oil content, the dew point pressure is reduced. It perfectly matches the characteristics of the near-critical condensate gas reservoir and fully explain the abnormal relationship of dew point pressure and GOR obtained in PVT test. All these three methods identify that the well X belongs to near-critical condensate gas reservoir or high condensate gas reservoir with near-critical characteristics. Okay, this table shows the calculation results of the empirical method for oil ring identification of the well X and well Y. The empirical methods include 4 categories and 15 methods, but none of them contain the definition categories, the corresponding range, and the characteristics of near-critical condensate gas reservoir. Thus, the reservoir type is determined to be condensate gas reservoir with oil rim. It can be concluded that for near-critical oil and gas reservoirs with GOR of 600 to 900, the oil rim empirical method is not suitable, and the reservoir type will be misjudged as condensate gas reservoirs with oil rim. In other words, the empirical oil rim discriminant method should be carefully used to distinguish the near-critical hydrocarbon reservoir type, and the result can only be used for reference. Okay, conclusion. So based on the well test, PVT test, and the reservoir type identifying methods, the well area of Shixi is determined to be a near-critical condensate gas reservoir. This is the first near-critical condensate gas reservoir discovered in Yangtze Basin. There are unique critical opalescence and fluid stratification phenomena for near-critical condensate gas reservoir. It is caused by the drastic change in the density of gas-liquid molecules during the significant gas-liquid phase transition. And the oil rim empirical discriminant method should be carefully used for near-critical reservoirs. The reservoir type may be misjudged as condensate gas reservoirs with oil rim. Okay,